this is Jo from Maths Tutor Me. Today we're doing probability, and we've come to the end of our topic on probability, so we're doing some revision today. So here's just a few questions going through each of the things that we've learned in this topic. So you can pause this video and you can try to do all these questions yourself and then come back to see the answers, or you can just go through them with me as I go. So let's go with question 1. List the sample space for the seasons in a year. Well, there are 4 seasons in a year, so we need to open some brackets. The 4 seasons are summer, autumn, winter, and spring. Okay, that's it. That's how we write a sample space. Question 2. The numbers 1 to 20 are written on cards and placed in a hat. Find the probability of selecting the number 7. Well, the probability of getting the number 7, there is only one number 7 in all those cards out of a total of 20 cards. So a probability of 1 in 20. Next, we want to find the probability of getting an odd number. Well, odd numbers are 1, 3, 5, every second number, isn't it? So that means there's going to be 10 odd numbers out of the 20, and we can simplify that, divide them both by 10, to be half. Half of the numbers would be odd. C, we want to find the probability that it's a multiple of 5. Okay, so that's our 5 times tables. So 5, 10, 15, and 20. That's 4 numbers out of 20. Now we could simplify those by dividing by 4. 4 divided by 4 goes once. 20 divided by 4 is 5. So there's a 1 in 5 chance of getting a multiple of 5. And we want the probability of getting a prime number. All right, well, let's have a think. What are the prime numbers between 1 and 20? Well, 1 is not prime or composite, so it doesn't count. 2 is a prime number. 3 is a prime number. 4 is not. 5 is. 6 isn't. 7, 8 is not. 9 is not. 10 is not. 11 is a prime number. 12 is not. 13 is a prime number. 14 is not. 15 is not. 16 is not. 17 is prime. 18 is not prime. 19 is prime. And 20 is not prime. So we have 1, 2, 3, 4, 5, 6, 7, 8 numbers that are prime out of our 20. Again, we can divide these by 4, which will give us a 2 on the top and a 5 on the bottom. All right, let's look at question 3. If there is a 65% chance that you will have potato for tea, what is the probability that you will not have potato for tea? When we're talking about percentages, the total of all percentages is 100. So if I take away the 65% chance that we will have potato, that means 100 minus 65 means that there is a 35% chance that you will not have potato for tea. Question 4. Find the probability of not rolling a 4 on a standard dice. Well, this is sounding like one of our complementary event things here. So what we can do is we can find the probability of rolling a 4. Well, there's 1 4 on a standard dice out of 6 numbers. If we want the probability of not rolling a 4, we would go 1 minus that, which is 5 out of 6 numbers. Because there's 5 numbers on the dice that are not a 4, isn't it? Okay, let's go on to the next page. Question 5. Out of 56 students, 36 like running, 29 like swimming, and 7 people do not like either sport. Draw a Venn diagram to show this information. So there is 2 sports that we're told about here, running and swimming. So a circle for running and a circle for swimming. Okay, so there's 56 students altogether. We know that 7 people do not like either sport, so we put them out here. They don't like either one. So we have running and swimming, but we need to work out our overlap. So what we do is if we had 56 students to start with, I'm going to take away the 7 that we know don't like either sport. So there's 49 students that are going to be in these circles here. But if we add together 36 plus 29, we have a much bigger number. We have 65. So if we take away the 49 that we need, that means that we have an overlap of 16 students that must like both sports. So if there's 36 students who like running, 36 minus the 16 means that there is 20 students that like running but not swimming. If there's 29 students in total that like swimming, take away the 16, means that there is 13 that just like swimming. So let's just add those up. It's always good to check. So if we go 7 plus 20 plus 16 plus 13 equals 56 students. Okay, so that's looking like our diagram's correct. Let's answer our questions now. Find how many students like running only. So just running, not swimming, there was 20 students. Okay, B, how many students like swimming only? So just swimming is the 13. And how many students like both sports? That's our overlap of 16 students. Question 6. The following two-way table shows the pass and fail rates of students in their math and English exams. So pass and fail, maths and English. First of all, we have to complete the table. We have some missing numbers. So if we have two numbers, so 56 and 14, we could add those together to get the total. 56 plus 14 is 70. Okay, we also have 70 as a total for this one. If I take away the 8, I would get 62 in this box. And then I could add these ones together to get the total down the bottom. So 62 plus 56 is 118. And 8 plus 14 is 22. Now I could add this way or this way and I should get the same result. Let's go 118 plus 22 and I get 140, and 70 plus 70 is also 140. So that's all worked out. So we've completed the table, we've done that. Now we want to use the table to find how many students passed the maths exam. So passing the math exam, pass and maths, that's 62. 62 students passed the maths exam. We now want to find how many students completed the English exam. So it doesn't mean, we don't know if they passed or failed, they just did the English exam. So English exam, how many students in total did the English exam? 70. And 3, the total number of failed papers. Okay, so how many people failed in maths or English? There was 22 fail papers. And that's it. That's the end of our little revision lesson. Hopefully you're getting those questions right and you're remembering all that we've learnt so far. Join me next time for a new topic. Bye.